Given the table above, does the limit as x approaches 0 of f of x exist, why or why not? Whenever you're asked a question if a limit exists, you're always thinking if the left-handed side and the right-handed side meet at the same spot. And if they do, whether you have a value at that limit doesn't even matter. It exists only if the left side and the right side meet at the same spot. Now, what we have here is, in this, we are, at negative 0.1 and then negative 0.0001, and then it hits 0. As we're approaching this value, as we're approaching 0 from the left, it appears, we are approaching 2. That's nice. However, as our number goes from 0.1 to 0.001 and we're going from the other side, we're approaching what appears to be 4-ish. So graphically, you're looking at something that looks like this and something that looks like this. And if that's the case, the left side and the right side are not going to meet up. So does the limit exist? No. And the reason why it's a no is because the left-handed limit and the right-handed limit are not approaching the same value, therefore the limit does not exist. Based on the values given, for which of the functions does it appear that the limit as x approaches 1 is 3? Whenever you're being asked if a limit approaches a value, you need to make sure that the left side and the right side are approaching the same value. So as we look at each of these, you have numbers going towards 1 from the left, so it's getting larger, and numbers going towards 1 from the right. As this happens, are they all headed towards the number 3? Well, let's take a look at h of x. H of x goes from 3-ish to 3-ish to 3-ish to 3, and this guy literally does the same exact thing but opposite. So since h of x appears to be heading towards 3 from the left and heading towards 3 from the right, we can assume that they're both heading towards 3, and you're going to get something that looks like this. So h of x is good. Now let's take a look at j of x. J of x, you're at negative 1, negative 1, negative 1, 3, 3, 3, 3. So graphically what that looks like is you have something way down here and then something way up here, and those do not meet at the same spot. So j of x is a no-go. K of x has you going to a number very close to 3, even closer, really, really, really close, and then undefined. However, on the other side, you have the same exact numbers, just going backwards. So what's probably happening here is you may have a hole, but it appears that that hole, or asymptote, exists at 3. And what's happening is these numbers are going to a number that's awfully close to 3, just never being 3, but that's okay. The limit does not have to be 3. The point of a limit is that it's heading towards that number. And since both the left side and the right side are headed towards the same number 3, we could say that k of x is also a function that has a limit as x approaches 1 of 3. So in this case, h of x is good, and k of x is good, and both of these are just fine. Consider the function f of x equals x squared minus 1 over x minus 1. Use the table below to estimate the limit as x approaches 1. Alright, well, in this, I know that I can't plug in 1, because if I plug in 1, I get something that's undefined. That's no good. And I also don't have the value 1 here. However, 0.999 and 1.01 are both awfully close to 1. Awfully close to 1. So these are almost 1. 0.999 and 1.01 are both also awfully close to 1. So if I were to kind of sneak a 1 in here and sneak a number in here, that number would also be 1. So I think it's safe to say that as this table approaches the number 1, my f of x values also approach the number 1. So we can logically say that the limit as x approaches 1 of f of x should also be 1. Even though I can't plug 1 in, that's not the point. The point is, am I allowed to have something in this direction headed towards the same exact value in that direction? And in this case, that seems to be what's going on, and the answer is going to be 1.